we begin a journey that takes us to the very limit of what is known. We are going to travel, in our minds, to the edge of the universe. It is a place of silence, of ancient light, and of profound mystery. But before we reach that distant frontier, let us settle into the present moment. Let us find a quiet space within ourselves, a stillness that mirrors the vast, serene emptiness of the cosmos. Take a deep breath. Let the air fill your lungs slowly, and then let it release just as slowly. With every breath, imagine the noise of the day fading away. The rush of traffic, the hum of electronics, the chatter of voices, all of it drifts into the background, becoming nothing more than a distant memory. You are here now, in a space of calm. Imagine you are standing in a wide, open field. The ground beneath you is solid and cool. The air is still. Above you, the sky is a perfect dome of velvet black, unblemished by clouds or city lights. It is the kind of darkness that feels heavy and comforting, a blanket wrapped around the world. And scattered across this darkness are the stars, thousands of them. Some are bright and piercing like diamonds, others are faint, dusty smudges of light that barely register to the eye. When you look up at this tapestry, you are looking into a deep well of time. The light from these stars has traveled for years, centuries, or even millennia to reach you. You are seeing the universe, not as it is this very second, but as it was. The night sky is a history book written in photons. It is a silent record of burning suns and swirling galaxies. As we gaze upward, we naturally wonder, where does it end? If we could travel past the moon, past the planets of our solar system, past the stars of the Milky Way, what would we find? If we kept going, flying through the dark voids between galaxies, passing island universes spiral after spiral, would we eventually hit a wall? Is there a boundary to this expanse? For most of human history, the edge of the universe was a philosophical question. It was a matter of myth and imagination. But in the last century, it became a matter of science. We learned that the universe is not static. It is expanding. It is growing, stretching out in all directions, carrying galaxies away from one another like driftwood on a rising tide. And because light takes time to travel, there is a limit to how far we can see. This is the first thing we must understand about the edge. It is not a physical barrier. It is not a cliff where space drops off into nothingness. It is a horizon. Just as a sailor on the ocean can only see as far as the curve of the Earth allows, we can only see as far as light has had time to travel since the beginning of the universe. We call this the observable universe. It is a bubble, a sphere of visibility centered on us. The radius of this sphere is about 46 billion light-years. Inside this bubble are all the galaxies, all the nebulae, all the matter and energy that we can detect. It is a staggering volume of space, containing perhaps 2 trillion galaxies, each with hundreds of billions of stars. But here is the thought that keeps astronomers awake in the quiet hours of the night. What lies beyond the bubble? What exists outside the sphere of our vision? Common sense suggests that the universe likely continues just the same beyond the horizon. More galaxies, more stars, more empty space. If you were teleported instantly to the edge of our observable universe, you would likely find yourself in the center of your own new observable universe, seeing things that are currently hidden from Earth. It would be a seamless continuation of the cosmic web. However, in recent years, scientists have found something that challenges this simple picture. They have noticed something peculiar in the way our galaxy, and the galaxies around us, are moving. It is a subtle clue, a whisper in the data, suggesting that the universe beyond our horizon is not just more of the same. They have found evidence of a presence, a massive silent influence that sits just beyond the veil of the observable universe. It is not visible to our telescopes. It emits no light that can reach us. But we know it is there because we can feel it. We can feel its gravity. Imagine you are floating in a calm, dark ocean. You cannot see land, you cannot see the currents, but you realize that you are drifting. Slowly, inexorably, you and everything around you are being pulled in a specific direction. You are caught in a flow. You cannot see what is pulling you, but you know it is vast. You know it is powerful. This is the reality of our position in the cosmos. We are moving. The Earth moves around the Sun. The Sun moves around the center of the Milky Way. But the Milky Way itself is moving, and it is not wandering aimlessly. It is streaming. It is flowing like a droplet of water in a great river, heading towards a destination we cannot see. Tonight, we are going to trace this river. We are going to follow the current of galaxies to understand what lies at the end of the stream. We are going to explore the discovery that suggests something lies beyond the edge, something so massive, so ancient, that it challenges our understanding of the universe's structure. Relax your mind. Let go of the need for complex equations or rigorous proofs. We are here to observe, to float, and to wonder. We are drifting towards the edge, guided by the silent pull of the unknown. Let us deepen our relaxation. Imagine the sensation of floating weightless in space. There is no up or down here. There is only the gentle, silent suspension of the void. You are safe. You are an observer, a ghost in the machine of the cosmos, watching the slow, majestic dance of gravity. To understand what scientists have found, we must first look at our own neighborhood. We live in the Milky Way galaxy, a barred spiral composed of gas, dust, and stars. It is beautiful and vast, but it is not alone. We have neighbors. The Andromeda Galaxy is our majestic sister, spiraling nearby. Along with the Triangulum Galaxy and about 50 smaller dwarf galaxies, we form a family. We call this family the Local Group. For a long time, astronomers believed that the expansion of the universe was the dominant force acting on these galaxies. We knew that space was stretching, pushing galaxy groups apart. We imagined the universe as a calm, expanding balloon, where every point moves away from every other point uniformly. But when we began to map the sky with greater precision, measuring the speed and direction of thousands of galaxies, a different picture emerged. The expansion is real, yes, but overlaid on that expansion is a flow. Imagine a crowd of people walking through a train station. Generally, the crowd is spreading out, making room. But within that spreading crowd, there are currents. Groups of people are streaming toward a specific gate. They are being drawn by a common destination. In the 1970s and 80s, astronomers discovered that the Milky Way was crashing through the universe at an incredible speed, about 600 kilometers per second. That is over 1 million miles per hour. We are not sitting still. We are hurtling through the dark. But we are not moving alone. Our entire local group is moving with us, and the clusters of galaxies near us, the Virgo cluster, the Centaurus cluster, they are moving too. We are all caught in a gravitational current. Scientists traced this motion. They mapped the vectors, the lines of travel for millions of light years. They found that we are falling. We are falling towards a region of space known as the Great Attractor. The Great Attractor is a gravitational anomaly. It is a concentration of mass so dense, so heavy, that it bends the path of everything for hundreds of millions of light years around it. It pulls the Milky Way, Andromeda, and thousands of other galaxies towards it. It sits in the direction of the constellation Centaurus, hidden behind the dust lanes of our own galaxy, shrouded in mystery. For decades, the Great Attractor was the biggest thing we knew of. It was the monster in the dark, reeling us in. We thought it was the end of the line. We thought it was the reason for our speed. But as our telescopes improved, as we peered deeper into the dusty veil, we realized something unsettling. The Great Attractor is massive, yes. It has the mass of tens of thousands of galaxies. But it is not massive enough. When astronomers calculated the speed of our motion, that's 600 kilometers per second, they realized that the Great Attractor could not account for all of it. It wasn't strong enough to be pulling us this fast. It was as if we were falling down a hill passing a large boulder. The boulder has gravity, it pulls on us, but the hill continues down, deeper and darker. The Great Attractor was just a waypoint. So, The gaze of science lifted. We looked past the Great Attractor. We looked further out, into the deeper universe. And we found the Shapley supercluster. The Shapley supercluster is a titan. It is one of the largest concentrations of galaxies in the nearby universe, a dense knot of matter far more massive than the Great Attractor. It lies about 650 million light-years away. It is a city of galaxies, bright and crowded. Ideally, this should have been the answer. The Shapley supercluster is pulling us. The Great Attractor is pulling us. Between the two, the math should balance. We should understand our motion. But the mystery only deepened. In the early 2000s, a team of researchers led by Alexander Kashlinsky at NASA began looking at something even grander. They weren't just looking at local galaxies, they were looking at the cosmic microwave background, the afterglow of the Big Bang itself. They were looking for the interaction between hot gas in galaxy clusters and this ancient light. By studying this interaction, they could measure how fast galaxy clusters were moving on a truly cosmic scale. Not just our neighborhood, but clusters far, far away. Clusters that should be disconnected from us. They expected to find randomness. In a universe that is generally uniform, the motion of distant clusters should be chaotic, cancelling each other out, some moving left, some right, some up, some down. That is not what they found. They found a river that spanned the visible sky. They discovered that galaxy clusters, separated by billions of light-years, were all streaming in the same direction. It was a coherent, unified motion, a flow. They called it the dark flow. Imagine looking at a vast ocean. You expect the waves to be choppy, moving in different directions based on the wind. But instead, you see the entire ocean for thousands of miles sliding smoothly in one single direction. As if the ocean floor tilted. As if a drain had opened at the end of the world. This dark flow was moving at incredible speeds, up to 1,000 kilometers per second. And most disturbingly, it was flowing towards a specific point on the sky. It was flowing towards the constellations of Centaurus and Hydra. But here is the crucial part. Here is where the chill of the unknown sets in. The source of this flow, the thing that is pulling these clusters, the thing that has enough gravity to drag a substantial portion of the observable universe, does not seem to exist within our observable universe. When astronomers look in the direction of the flow, they see the Great Attractor. They see the Shapley supercluster. But even Shapley is not enough. The math implies that the mass required to generate this kind of pull is colossal. It would need to be a structure of matter bigger than anything we have ever seen, bigger than anything the laws of cosmology allow to exist. And based on the speed of the flow, the source lies beyond the horizon. It lies beyond the edge of the universe we can see. We are like ships caught in a current, drifting toward a waterfall that is hidden in the fog. We can calculate the speed of the water. We can feel the pull. We can point to the direction we are going. But the cause, the destination, is hidden behind the curtain of light time. Something is out there. Something massive. Something that sits in the unobservable regions of space, silently reeling in the galaxies. Let us pause here and feel the weight of this idea. We often think of the universe as what we can see. If we can photograph it, it exists. If we cannot, it is nothing. But the dark flow suggests that our bubble of vision is just a small patch in a much larger, much stranger landscape. The observable universe is merely a clearing in a dark forest. We can see the trees at the edge of the clearing, but we can feel the wind blowing from deep within the woods. We can hear the rustling of leaves from places our light has not yet reached. What could be massive enough to pull the universe? Is it a superstructure of matter, a wall of galaxies billions of light-years long, or is it something more exotic? Some scientists have whispered about the influence of other universes. A neighbor universe rubbing up against ours, its gravity leaking through the veil. We are drifting. The Milky Way. The Earth, the Sun, and you, sitting quietly in this room. We are all streaming through the void at millions of miles per hour, drawn by a ghost. As we continue this journey, we will explore the theories of what this structure might be. We will try to visualize the topography of the cosmos, not as a flat map, but as a dynamic, flowing terrain of hills and valleys, where we are sliding down the longest slope of all. Rest in this motion. There is no need to be afraid. This drift has been happening for billions of years. It is the natural state of things. We are travelers in a river of stars, and the current is guiding us into the unknown. Let us return to the sensation of drifting. You are still floating in that boundless, quiet ocean of space. The stars are all around you, burning steadily in the dark. We have established that we are moving. We, along with billions of other stars and galaxies, are sliding through the universe, caught in a current that flows toward a horizon we cannot see. But to understand what might be pulling us, we must understand the fabric of the ocean itself. We must look at the architecture of space. For a long time, we pictured the universe as a simple box. Things were inside the box: stars, planets, us, and space was just the emptiness between them. But in the grand narrative of cosmology, space is not empty. It is not nothing. Space is a substance. It can bend. It can twist. It can stretch. And, most importantly for our journey, it can ripple. To understand the something beyond the edge, we have to travel back to the very beginning, before the stars, before the galaxies, before the darkness itself. We must go back to the first fraction of a second of existence. Scientists call this moment inflation. Imagine a single drop of ink falling into a clear glass of water. For a moment, it is small, concentrated. Then it explodes outward, clouding the water, expanding in complex, swirling patterns. Now, imagine that expansion happening not in a glass, but everywhere at once. And imagine it happening faster than the speed of light. In a fraction of a second, so small that human language has no word for it, the universe went from the size of a proton to something vast, something macroscopic. This violent, silent expansion stretched the fabric of space smooth. It is like taking a wrinkled sheet and pulling it tight from all four corners. The wrinkles disappear. The surface becomes flat and uniform. This is why, when we look up today, the universe looks largely the same in every direction. The distribution of galaxies to the left looks very similar to the distribution of galaxies to the right. But, and this is the crucial whisper in the dark, what if the sheet wasn't pulled perfectly tight? What if the expansion wasn't perfectly uniform? Imagine baking a loaf of bread. As the dough rises, it expands. Generally, the loaf keeps its shape. But sometimes there are irregularities. A pocket of air here, a denser patch of dough there. As the loaf grows, these tiny imperfections grow with it. A microscopic grain of flour becomes a mountain. A tiny air bubble becomes a void. The dark flow. This river of galaxies we are caught in might be the result of one of these ancient imperfections. Some cosmologists believe that what lies beyond the edge of our observable universe is simply a tilt in the fabric of space-time, a remnant of that initial expansion. Imagine that the universe, on a scale much larger than we can see, is not flat. Imagine it is a hill. We are living on the slope of this cosmic hill. We cannot see the peak, and we cannot see the valley below. The horizon of our observable universe cuts off our view. But we can feel the slope. We can feel gravity pulling us downhill. This theory suggests that the something pulling us isn't a single object. It isn't a monster galaxy or a black hole. It is the structure of the universe itself. We are sliding down a gradient that was carved into the cosmos at the moment of its birth. There is a beauty in this idea. It connects our motion today, the movement of our sun, our earth, our bodies, to the very first breath of creation. We are still feeling the aftershocks of the Big Bang. We are still riding the wave that started it all. But there is another piece to this puzzle, a piece that adds a layer of eerie symmetry to our journey. If we are being pulled towards something in the distance, it stands to reason that we might also be pushed away from something behind us. In 2017, a team of astronomers mapping the flows of the local universe found exactly that. They looked at the direction opposite to the flow. They looked behind us, cosmologically speaking. and they found a void. Space is not filled evenly with matter. There are clusters where galaxies huddle together like cities in the night. And there are voids, vast spherical wastelands where almost nothing exists. No stars, no galaxies, just millions of light years of empty, cold dark. Behind our Milky Way, in the direction opposite to where we are falling, lies a region of space that is incredibly empty. It is more than just a lack of stars. It is a region where the density of the universe is significantly lower than average. Scientists named this region the dipole repeller. It sounds like something from science fiction, but the physics is simple and elegant. Gravity is a force of attraction. Dense things pull. But in a universe that is everywhere full of stuff, an empty spot acts like a repeller. Think of it like a crowded room. If everyone is pushing and shoving and suddenly a space clears out in the back of the room, the pressure from the crowd will naturally push you away from the empty space and towards the crush of people. You aren't just being pulled by the crowd, you are being pushed by the emptiness. So, here is our situation. We are caught between a push and a pull. Behind us, the dipole repeller, a vast nothingness, shoves us forward. Ahead of us, the Shapley supercluster and the mysterious dark flow drag us onward. We are surfing on a gravitational wave, a cosmic tide that spans billions of light years. Take a moment to feel the scale of this. The force that moves you is not just the gravity of the Earth holding you to your chair. It is not just the Sun holding the Earth in orbit. It is a push and pull mechanism that operates across the entire visible universe. You are part of a flow that is larger than imagination. You are part of a structure that is vast, silent, and incredibly ancient. And yet, even this, the repeller, the attractor, the flow, might just be the beginning. For beyond the horizon, beyond the tilt of the universe, there are theories that whisper of something even stranger. They whisper of neighbors. Let the silence of the void deepen around you. The stars are steady. The drift is constant. We have traveled to the edge of the observable universe, and we have felt the slope of the hill we are sliding down. Now, we must ask the question that borders on the metaphysical. Is our hill the only hill? Is our universe alone? For centuries, the universe meant everything. By definition, there could be nothing outside of it, because if there were, it would be part of the universe. But modern cosmology has begun to fray the edges of this definition. It has introduced a new word, a word that is both thrilling and terrifying: the multiverse. The idea arises from the same theory of inflation we touched upon earlier. Remember the bread dough expanding. Remember the bubbles forming. Eternal inflation is a theory that suggests the expansion of space didn't stop everywhere at once. It suggests that the greater universe, the bulk, is essentially a vast, eternally expanding sea of energy. In this sea, bubbles of stability form. When a bubble forms, inflation stops inside it. The energy condenses into matter. Stars form. Galaxies spiral. Life emerges. Our universe. Everything we see, everything we know, from the Big Bang until now, might be just one of these bubbles. Floating in that eternal sea, far beyond our horizon, there could be other bubbles, other universes. They might be vastly different from ours. Maybe their physics are different. Maybe gravity is stronger there, crushing stars into diamonds. Maybe light travels slower. Or maybe they are similar to ours, vast, starry, filled with the same silence. Now, why does this matter for the dark flow? Why does this matter for the something scientists found beyond the edge? Because bubbles can touch. Imagine two soap bubbles floating in the air. They drift, they wobble, and sometimes they bump into each other. When they touch, they don't always pop. Sometimes they press against each other, flattening their sides, creating a circular rim where they meet. Some physicists have proposed a stunning possibility: the dark flow, that mysterious pull dragging our galaxy clusters towards the constellation Centaurus, might be the gravitational wake of a collision. It is possible that eons ago, or perhaps even now, another universe bumped into ours. It wouldn't be a violent crash like two cars hitting. It would be a slow, massive interaction of higher dimensional geometries. The mass of that other universe, sitting just outside the skin of our own, would exert a gravitational pull. It would tug on the galaxies in our bubble, drawing them towards the point of contact. We wouldn't be able to see this neighbor. The space between universes prevents light from traveling from one to the other. But gravity is relentless. Gravity leaks. Gravity might be the only signal that can cross the boundary. So, when we look at the dark flow, we might be looking at a bruise on the sky. We might be feeling the tug of a sibling universe passing us in the night. There is evidence that hints at this. When scientists look at the cosmic microwave background, that baby picture of the universe, they see a strange anomaly known as the cold spot. The cosmic microwave background should be roughly the same temperature everywhere. But there is one spot, a large circular patch in the southern hemisphere, that is significantly colder than it should be. It is a hole in the heat. A mystery. For years, we tried to explain it away as a statistical fluke or a super void, but the multiverse theory offers a different explanation. The cold spot could be the imprint of the collision. It could be the dent left behind where another bubble pressed against ours, pushing matter away, cooling the energy in that region. If this is true, the implications are profound. It means the edge of the universe is not the end of reality. It is merely a border. It is the wall of our room, but there is a whole house outside. Close your eyes for a moment and try to visualize this. You are not just in a galaxy, you are in a bubble, a sphere of light and matter floating in a timeless, expanding ocean. And out there in the dark, impossibly far away but physically real, are others. Some might be young, just igniting with their first stars. Some might be old, dark, and cold, their energy spent. Some might be so close that their gravity is reaching out, like a hand in the dark, brushing against the shoulder of our Milky Way. The something beyond the edge is not a monster. It is a companion. This perspective shifts everything. It takes the loneliness of the cosmic void and transforms it into a feeling of connection. We are small, yes. We are microscopic specks on a dust mote in a single bubble of foam. But we are part of a structure so grand, so complex that it defies comprehension. We are part of the landscape of the multiverse. The flow that carries us is not a death march. It is a procession. We are moving in concert with the structure of all things. The atoms in your body, the light from the sun, the dark matter binding the galaxy. It is all dancing to the music of spheres that are larger than universes. Let this feeling settle in your chest. It is a heavy feeling, but not a crushing one. It is the weight of awe. It is the realization that the mystery is not just out there far away. The mystery is here. We are in the grip of it right now. As we drift towards the constellation Centaurus, dragged by the dark flow, pushed by the dipole repeller, potentially beckoned by a neighbor universe, we are participators in the greatest journey existence has to offer. We are not lost in the dark, we are flowing through it. In the final part of our journey, we will let go of the theories. We will let go of the need to solve the puzzle. Instead, we will surrender to the flow itself. We will look at what this means for the future, for the universe, and for us, the silent observers of this majestic cosmic drift. And so, we drift. We have spent this time together floating in the dark, tracing the invisible river that carries the Milky Way, Andromeda, and thousands of other galaxies through the void. We have looked past the stars, past the dust, and past the limits of our own vision. We have felt the pull of the great attractor, the shove of the dipole repeller, and the ghostly tug of the dark flow. We have learned that beyond the edge of the universe, beyond the wall of light that defines our reality, there is something, a structure, a tilt, perhaps even a twin. Now, as our journey nears its end, a final question arises. It is a quiet question, whispered in the space between heartbeats. Where are we going? If we are moving at millions of miles per hour, if we are falling towards this massive unknown, will we ever arrive? Will we ever crash into the source of the flow? The answer is one of the most poignant truths in all of cosmology. We will never get there. The universe is expanding. Space is stretching. While gravity pulls us toward that distant horizon, the ground beneath our feet is growing. The distance between us and the source of the dark flow is increasing every second. It is a cosmic race. We are running as fast as we can, caught in this gravitational current. But the finish line is moving away from us faster than we can swim. The expansion of the universe is relentless. In time, it will push the edge of the visible universe further and further away, taking the source of the flow with it. We are chasing a ghost. We are sailing toward a sunset that will never dip below the horizon, but will never rise to meet us either. There is a profound sadness in this, perhaps, but there is also a deep, abiding peace. It means that the journey is eternal. We are not traveling to a destination that will end our story. We are traveling for the sake of the travel itself. We are permanent voyagers in a universe that is designed to keep secrets. Imagine the timeline of the future. Billions of years from now, our sun will swell and fade. The Earth will change. The Milky Way and Andromeda will finally meet, merging in a slow, graceful collision of light and gravity to form a single, massive elliptical galaxy. We will become Milkomeda, a new island of stars. And through all of that transformation, through the birth of new suns and the death of old ones, we will still be flowing. That giant, new galaxy will still be sliding through the dark, guided by the ancient tilt of the Big Bang, pulled by the invisible hand from beyond the edge. The flow is the one constant. It is the heartbeat that underlies the chaos of formation and destruction. In the far, far future, when the expansion of the universe accelerates, dragging distant galaxies out of our view entirely, the sky will darken. The rest of the cosmos will disappear from our sight, carried away by the stretching of space. Future civilizations, if they exist, might look up and see only their own galaxy. They might think they are alone in an empty void, but they won't be static. Even in that loneliness, they will still be moving. They will still be part of the river, even if they cannot see the shore. The something beyond the edge will still be pulling them, a silent reminder that they are part of a greater whole. This is the comfort of the discovery. We often fear the unknown. When we hear that scientists found something beyond the edge of the universe, our instinct is to imagine a threat, a void, a monster. But the reality is much softer. The reality is that we found a connection. The something is gravity. And gravity in its purest form is a relationship. It is the universe holding hands with itself. It is matter calling out to matter across the dark. The fact that we are being pulled means we are not isolated. We are not forgotten debris floating in a random chaos. We are part of a system. We are part of a structure so vast that it dwarfs the imagination. A structure that might span across multiverses, connecting bubble to bubble in a web of cosmic foam. We are home. The universe is not a cold, indifferent place. It is a flowing, moving, dynamic ocean. And we are the water. Take a moment now to return to yourself. Feel the gravity of the Earth. It is the same force. The same force that pulls the galaxy is pulling you to your bed, to your chair, to the ground. You are connected to the flow. Close your eyes if you haven't already. Let the image of the stars fade gently from your mind. Replace the vast, swirling maps of superclusters with a simple, warm darkness. You are safe here. You are small, but you are significant. You are an observer of the great mystery. The edge of the universe is not a wall. It is a horizon. And horizons are beautiful not because of what they hide, but because they promise that there is always more. Always further to go. Always more to dream. As you drift into sleep or into the quiet rest of your day, carry this feeling with you. The feeling of being carried. The feeling of being part of the great flow. The universe is breathing. The galaxies are drifting. And you are right where you belong. Good night, traveler, and journey well.